Okay, so this is just a few hints to help you with the homework that I set you over Easter. First of all, the conversions. I'm hoping this is pretty straightforward for most of you. So a decimetre cubed is the equivalent to 1,000 centimetres cubed. Now 1,000 centimetres cubed is also equivalent to 1 litre, but here we're just going between decimetres cubed and either centimetres cubed or litres and mils. So it should be fairly simple. Now starting with the first one there, 1,000 centimetres cubed. If we know there are 1,000 centimetres cubed in 1 decimetre cubed, then you know that's going to be 1 decimetre cubed. So what we do to go from decimetre cubed to centimetres cubed is we divide by 1,000. The rest of it I'm hoping is fairly straightforward. This one here we're going the other way round. So here we're starting off with decimetres cubed and we're changing into centimetres cubed. So think about it, you're starting off with something that's equivalent. Each one of these 1 decimetres cubed is equivalent to 1,000 centimetres cubed. You're going to end up with a large number, aren't you? So this time you're multiplying by 1,000. Okay, now this is the one that some of you have been struggling with. And this is the kind of thing that you get at the end of, for example, a calculation, a calorimetry calculation, where you say you've burnt 2.3 grams of ethanol and you've done your Q equals mc delta T calculation and you found that it releases 50 joules of energy. But that tells you it's 50 joules of energy. It's alright, my 3 kids are stood behind me. That's 50 joules of energy from 2.3 grams of ethanol. I might have to pause here. So effectively what this is saying is 2.3 grams of ethanol gives you 50 joules of energy. What about how much do you get for every mole of ethanol? Well then first of all you've got to work out how much, what the mass of a mole of ethanol is. So I can tell you that it's CH3CH2OH, so that's 15 plus 15 is 30 plus another 16 for the oxygen, 46. So 1 mole of ethanol weighs 46 grams. Now you haven't got 46 grams here, you have 2.3 grams. So the first step is just to work out how many moles of ethanol you have. Once you know how many moles of ethanol you've burnt here, you've then got to try and convert that to how much you would have got if you'd got 1 mole of ethanol. I'm not going to tell you any more than that for now, but look back at when we did the calorimetry calculations, look back at that kind of thing, and you should be able to work your way through this. So each time, this is how much energy you get for a certain mass of fuel. What you're trying to work out is what would happen if you had 1 mole of that fuel. Now for the concentration calculations, what I'm saying here is if I have 4 grams of sodium hydroxide in 2 decimetres cubed of water, I want to work out the calculation in grams per decimetre cubed. So basically that's how much I have in 2 decimetres cubed, how many grams would I have in 1 decimetre cubed. Here it's telling you how much you have in 50 centimetres cubed, so you need to find out how many of these 50 centimetre cubed there are in 1 decimetre cubed, and then multiply that by the gram because you've only got a portion of it there. Now this number 2 here, it's asking you basically to say, well alright, if I have 4 grams of sodium hydroxide, how many moles is that? And from there you can work out how many moles there would be in a decimetre cubed. And the final one here, oh no, we've got 2 more left, concentration in moles per decimetre cubed. Alright, so here it's told you the number of moles and it's given you a volume of water, but so that's 0.05 moles in 25 centimetres cubed. So how many moles would there be in 1,000 centimetres cubed? Now all of this one here, for example, number 3, you should have found out about an equation which is concentration is equal to the number of moles divided by the volume. So if that's the way that you want to do it, you can do that. You can just do 0.05 divided by 25. However, what you do have to take into account is that 25 centimetres cubed, you're in centimetres cubed here, and you need to convert it first to decimeters cubed. Again, I'm not going to tell you anything more than this. See if you can get through it, and I will go through this properly after the lesson. And here, again, we've got a mass, we've got a volume, so you need to work out. So if you use your concentration equals a number of moles over the volume, you can use that to work backwards for this.